In this series of videos, we're going to actually look at how to calculate an empirical formula. So what is an empirical formula? It is simply the simplest ratio. Now it differs from a molecular formula because a molecular formula actually tells you the number of atoms of each type present in the compound. So let's look at an example. So if you look at water, its molecular formula is H2O. Now if you look at the ratio, it's got 2 hydrogens to 1 oxygen, and that's actually the simplest ratio, so its empirical formula is the same. But when you come to hydrogen peroxide, it's got a formula of H2O2. Now that means you've got 2 hydrogens to 2 oxygens, so its empirical formula 2:2 would simplify down to 1:1, which is HO. Methane has a molecular formula of CH4, so it's got 1 carbon to 4 hydrogens. And you can see that's actually the simplest ratio, so its empirical formula is the same. Ethene has a formula of C2H4. So it's got 2 parts carbon to 4 parts hydrogen. So the simplest ratio would be CH2, 1 part carbon to 2 parts hydrogen. Ethine has a molecular formula of C2H2. So it's got 2 parts hydrogen to 2 parts carbon. So it would simplify down to CH, 1:1. Benzene, C6H6, 6 parts carbon to 6 parts hydrogen, will simplify down to CH. You'll notice that these two have the same empirical formula. Glucose, C6H12O6, so 6 parts carbon to 12 parts hydrogen to 6 parts oxygen. 6:12:6 will simplify down to CH2O. 1 part carbon to 2 parts hydrogen to 1 part oxygen. And glucose, C12H22O11, well, its simplest ratio is still going to be the same, so C12H22O11. Now let's look at how to calculate an empirical formula. Now first you're either going to find a percentage or mass of the elements in the compounds. Now remember, a percentage is simply a mass out of 100. You're going to create a table. Now it's really important here that you're organised and it's beautifully set up, because this will make it much easier for your marker. You then go through and find the moles of each element. Then you find the simplest ratio by dividing by the smallest number of moles. You determine the empirical formula. Now usually a problem doesn't stop there. There are usually another 2 parts to the problem. Now the next part would be to calculate the molar mass. Now this can often be done by using PV equals nRT, or the number of moles equals mass over formula mass, but you'll use another formula probably to calculate the molar mass. Now once you have done this, you can find the ratio of the molar mass to the empirical formula, and this will allow you to determine what number you're going to times your empirical formula by to determine the molecular formula. Now let's look at an example. A poisonous compound isolated from rhubarb consists of 19% carbon, 4.8% hydrogen, and the rest oxygen. Calculate its empirical formula. So there's the first part of our problem. Now the second part of the problem is usually about how you can find the molecular formula. And you'll see here that it's given the compound's molecular mass. So this is quite a straightforward problem, and it occurs as a dihydrate. Write its molecular formula. Now later on, as the problems get more difficult, they'll usually also provide some information about how you can draw the structure, but we'll deal with that later. So let's try and set this problem up. So for a start, we don't know how much oxygen is present. So off to the side here, I'm just going to go, the mass of oxygen is going to equal 100 because it's a percentage, so it'd be out of 100 minus 19 minus 4.8. And this will come out to 76.2%. or grams out of 100. So setting up our table. So the first thing you need to do is put the titles at the top: carbon, hydrogen and oxygen. Now the next part is the mass. Now we're doing a mass out of 100, so it's 19, 4.8 and 76.2. Now we're going to find the moles. Now in order to find a mole, remember the number of moles is always equal to a mass over a formula mass. So the number of moles in this case will be 19 divided by 12.01, 4.8 divided by 1.008 and 76.2 divided by 16. And I got those off the periodic table. Now the moles then come out to 1.582, 4.762 and 4.762. Now I've actually stored all of those pieces in my calculator. Now to get the simplest ratio, we divide by the smallest, and you can see here the smallest here is 1.582. So we're going to divide the whole lot by 1.582. so we can get the simplest ratio. So if you do this, obviously this one will come out to 1, this will come out to 3, and this will come out to 3. So the empirical formula then is CH3O3. Now we're moving on to the second part of the problem. So the second part of the problem is about how to work out the molecular formula. So we've been told that the compound's molecular mass is 126. We need to work out the empirical formula mass so that we can do a ratio. So the ratio is always going to be equal to the molecular formula divided by the empirical formula. So in this case it's 126, which is given in the problem. And now to work out the empirical formula mass, I go carbon is 12.01, add 3 times 1.008, add 3 times 16, and this comes out to about 63. So 126 divided by 63 comes out to about 2. So this is telling me that the molecular formula must be C2H6O6, and you can see how I did that. I simply times these numbers here by 2. So 1 times 2 is 2, 3 times 2 is 6, 3 times 2 is 6. Now the question also tells us that it occurs as a dihydrate. Now a dihydrate means it's got 2 lots of water attached. So let's work out what its actual formula is going to be. So there's no carbons in water, so it's going to be C2. And if you use 2 times 2 is 4 hydrogens, so there's 2 left. And 2 oxygens from 6 is O4. So the formula is C2H2O4.2H2O, which is called oxalic acid. Now I need you to try some yourself. So go to the OneNote calculations, and the first page on empirical formula, there's some very simple ones for you to try. I've created the worked examples and put them on space so that you can actually look at me doing them if you need help.